Good evening to all of you and welcome to Augmintech. So hope all of you are fine and doing well. So first, let me know all of you. Am I audible for all of you? Please in chat box give me answer yes no. Am I audible for all of you? Please give me answer yes no. Okay, good evening. Okay, okay. And uh, and make sure before starting again I am repeating here, please be active in my webinar, okay, please, so you will get lots of things. So here, before starting the webinar, okay, because here this webinar is for which topic? Duct designing method or duct sizing method. Okay, so before starting I will just introduce myself in short. Okay, so myself, Mohammad Sajjad, and I am an mechanical engineer with expertise in MEP designing and modeling field. Okay, with several years of experience in industry, I have a deep understanding of technicalities involved in MEP designing and modeling field. Okay, I have done many live projects, including residential, commercial buildings, hospitals building. Also, we have designed malls, retail shops, and more. So this is all about me in short. Okay. So again, please, all of you, my voice is clear, na? Give me reply, please, in chat box. Okay. So yeah, before starting this webinar, okay, first some announcement are there. So listen carefully. The first announcement is that we are not providing any recording of this webinar. Okay. So this is completely live class. Okay. So if you want to get deep knowledge in duct designing method, so be joined till the last, okay, till the end of this meeting webinar. Okay, so we are not providing any recording class. First announcement. Second one, after the end of this lecture, end of this webinar, we will offer some special offer to you. So okay, we'll provide some special offer, but that offer I will announce in the last. Okay, so can we start now? Tell me all of you. Okay. So here today the webinar is on which topic? Duct designing method. All of you know. Okay. And you can also say duct sizing method. So all of you know that we have a three types of duct sizing method or duct designing methods. What are that? First is the equal friction method. Okay. Second, velocity reduction method. And third one is the static regain method. Okay. So these three methods we have to discuss here in detail. Okay. If you are a HVAC engineer or maybe if you are a fresher in HVAC, no problem. Here I will start from scratch and give you a deep knowledge. I know that after completion of this webinar, uh, remember you will get the deep knowledge in duct designing method. You will able to design duct easily. Okay, so stay with me till the end of the class and let's start now. So before starting, first you have to know about the duct. What is actually duct? In HVAC system we are using duct, na? Duct work. So what is the main purpose of duct? Simple. In HVAC system, ducts are channel or you can say passage. Okay, generally used to distribute air throughout a building. If you are using air handling unit, fan coil unit, or any ductable split AC. So generally duct, the main purpose of duct is it working as a passage. Okay. Suppose from the air handling unit, okay, you want to supply the conditioned air to the multiple room. So how it is possible? With the help of duct. Duct is act as a channel or passage. So through this duct work, we are supplying conditioned air from a air handling unit or fan coil unit or any equipment. Okay, from that we are supplying conditioned air to each and every room. Okay, so this is the main purpose of duct. Clear? Duct are typically made of metal, fiberglass, or other material and are designed to deliver conditioned air. See, from the HVAC unit to various room or area within a structure. Okay, so this is the main purpose of duct. So all of you understood? Let me know, please. If anyone have doubt, okay. Suppose in between the class, if you anyone are facing any type of problem, so you can ask me, no problem, in chat box. Give me any question if you have, you can ask me. Okay. If it is possible, so I will give you the answer. That otherwise, wait for some time. We'll give you. Okay. So let's see now. Huh. So all of you understood now what is duct? Actually, before starting the duct designing method, this basic thing is important. Okay. So let's see. Then we start that. So duct, all of you know that duct comes in various shapes and size, including round duct, rectangular shape, oval. Depending on the specific requirement of the HVAC system and the building layout, we have to use the duct, because each and every duct shape has their own advantages and disadvantages. Okay. But in normal, you have seen, I think, inside, normally we are using which shape of duct? Rectangle. What is the reason? Because inside, all of you know that the space availability is very important. We do not have that much of space above the false ceiling I'm talking about. Okay. Generally, architecture will not give you that much of space, okay, to run the services properly. So the height issue is very important inside. Always we have to face the height issue if you run the HVAC or MEP service at any like firefighting pipes, plumbing, duct. So height, we have to face the height problem, height issue. So here, if you are using the rectangular duct, so you can reduce the height by increasing the width of duct. So the cost of rectangle duct is high as compared to round and square shape. But then also we are using rectangular duct because the reason is what? Same way, height is not available inside. Okay, so that is why in rectangular duct, we can easily reduce the height by increasing the duct width. Okay, so remember this thing. Clear this thing? Tell me, they can be installed in ceiling, walls, floors, or within the building structure itself. Generally, you know that above the false ceiling only, we have to run the duct work. Okay. Please give me reply. Don't be keep quiet, all of you. Understood what is duct in detail? Yes, please fast. Yes, no. In chat box, please give me your reply so we can. Okay. So this is all about the duct. Now let's see duct pressure. So what is duct pressure? So remember, airflow through duct system create three types of pressure. What are that? First is the static pressure. Second one is the velocity pressure. And third is the total pressure. Okay, so airflow in duct system creates three types of pressure: static, velocity, and total pressure. So each and every we have to discuss each pressure in detail. So let's see what is actually static, because remember, these terms are very important before starting the duct sizing method. Okay. So don't worry about, someone is asking me how much clearance should be between beam bottom and duct. So remember, clearance minimum is 100 mm after placement of insulation and everything. 100 mm minimum gap you have to maintain from the false ceiling, also from the slab. And suppose if any beams is coming, so 100 mm minimum gap we have to maintain. Okay, after the placement of insulation. So let's see now. What is the static pressure, all of you? Let's see. Static pressure is what? Static pressure in ductwork refers to the pressure exerted by the air inside the duct system when it is not in motion. Okay. So the pressure exerted by the air inside the duct when it is not in motion, that is called as a static pressure. So generally, the device which we are using to measure the static pressure is what? A manometers. Okay. U2 manometer is generally used to measure the pressure, static pressure, okay, in the duct system. So different devices are there. It is essential the force that the air exert on the walls of the duct and is measured in which unit? Inches of water column or in Pascal. Okay, so this is your static pressure. Second is the velocity pressure. This is the basic term. That is why I'm explaining a little bit fast, I think. Okay, so all of you understood now. If anyone facing any problem, so you can just give me message in chat box. Okay. Let's see now velocity pressure. So velocity, as the name indicate, means just a velocity pressure is what? The pressure exerted by the air due to its velocity as it moves through the duct. That is called as a velocity pressure. Okay. It is a component of the total pressure within the duct system and is typically measured in inch of water column or in Pascal. So when air moves through a duct, what happens? All of you know that it gains kinetic energy due to its velocity. So this kinetic energy contributes to the pressure exerted by the air, known as velocity pressure. Okay, so same velocity pressure also you can maintain. Where to find out the velocity method? Here we have a formula also. Let's see the formula. Velocity pressure is equal to 1.5 into air density into air square of air velocity. Okay. Air density means it is the density of air in the duct, typically measured in unit kg per meter cube or pounds per cubic meter. So both unit is given here, metric and imperial. Okay. And air velocity is the velocity of the air flowing through the duct, and it is measured in meter per second or feet per second. Okay. So by using this formula, you can easily measure the velocity pressure. Clear? Now next, the total pressure. So total pressure is what? Simple. Total pressure in ductwork refers to the combined pressure exerted by air due to both its velocity, okay, and its static state as it flow through the ductwork. Their formula is simple. It is also measured in same inch of water column or Pascal. To find out the total pressure, we have a formula: velocity pressure plus static pressure. So you will get the total pressure. Now the question is here, okay, this is our static, velocity and total pressure. Now how we can measure the pressure inside in the duct system? So as I told you, we have a different devices. Several devices are there to measure the pressure in duct system. So in that, here the first device name is given manometers. So all of you know that manometer is a device, simple, okay, which is used to measure the pressure difference between 2 points. Okay. As I told you now, generally a YouTube manometers are used to measure the static pressure difference in a duct system. Okay. Second, we have a pressure gauge. All of you know about the pressure gauge, I think. Okay. What is the use of pressure gauge? Tell me, please. Yes, fast. Give me reply in chat box so we can, because don't be keep quiet. I have told you in starting that in my webinar, please all of you be active. Okay. So you will understood everything. So please let me, anyone, pressure gauge is what? Simple. Pressure gauge is what? It measure pressure gauge. It is also a device that measure absolute and gauge pressure in a system. Okay. Generally, pressure gauge installed at the outlet of the air handling unit. Okay. To monitor the system pressure. Okay. Next device is given here, Bourdon tube pressure gauge. So here Bourdon tube pressure gauge means simple. Here what happened, this Bourdon tube pressure gauge uses a coil tube to measure the pressure. Okay. Generally this type of pressure gauge we are using for high pressure air distribution system. Okay. Where we have to use the Bourdon tube pressure gauge for high pressure air distribution system. Okay. Remember this point. Clear? Next, some other devices are also there, like digital pressure gauge is also there. All of you know digital pressure gauge is also a mechanical device. Generally, that electronically, what they are doing, electronically measure the pressure. Okay, digital pressure gauge, electronically measure the pressure. Okay. And just display the value digitally. So that is why it is called as a digital pressure gauge. So generally in our HVAC system, where we have this type of pressure gauge, digital pressure gauge, installed in the main duct to measure the real-time static pressure. Okay. Next, we have a pressure transducer. Pressure transducer just convert the pressure into electrical signal. This is the main function of pressure transducer. Generally, we are using in a VAV system, variable air volume system. I think all of you hear about this variable air volume system in HVAC. Okay. So generally, pressure transducer is used in variable air volume system. For what purpose? Yes, anyone? It giving a feedback. It provide feedback, okay, to the control system for adjusting flow rate, air flow rate. Okay. So this is the main purpose. Next, we have a finally differential pressure transmitter. This is also a mechanical device which is used to measure the difference pressure difference, okay, between differential pressure difference is transmitter is also a device which is used to measure the difference between two pressure point, okay. And generally this type of it is commonly used in air filter, okay, and duct system, okay, to measure the pressure drop, okay. So these are the six devices I have discussed to measure the pressure in duct system. All of you clear up to here? Tell me. So these are the basic thing which I have discussed. Now from here we have to start the duct sizing method. So generally for duct sizing or for duct designing, generally we have a three methods. So there are three methods of duct sizing. What are that? Generally, the most widely used method to size ducting is the equal friction method. Okay, that I will explain you the reason also why we are using equal friction method in most of the condition. Okay, so the other method are velocity reduction and static regain method. So let me all of you tell me what are the three method of duct sizing. First is the equal friction method, second velocity reduction method, and third one is the static regain method. So first I will explain you how we have to size the duct by using equal friction method. So first I will show you the equal friction method of duct sizing. Okay, equal friction duct sizing method. Then we have to go further velocity and static regain. And in which area generally we have to use the equal friction method for duct sizing. Okay, that all in detail. So first, equal friction. So what do you understand by this equal friction method? Anyone, please, in group? What do you understand by equal friction method? What is mean by equal friction method? Yes, anyone? If you know, so you can, without any hesitation, just give me message in chat box. If you don't know, no problem. Yeah, someone is telling to maintain friction through the duct. Okay. Someone is telling, okay, 0.08. No, I'm not talking about how much friction head loss we have to maintain. Here I'm asking, what is equal friction method? Simple. So no problem. Let's see. Equal friction design method size the duct for a constant friction rate or constant head loss, which describe the average pressure drop per 100 feet of duct in a system. Means in this method, if you are using equal friction method for duct sizing or for duct designing, so here remember at every 100 feet of duct length, you have to maintain the constant head loss or constant friction rate. Okay. So a very common friction rate for a reasonably well-designed system is 0.1 inch of water column per 100 feet of duct length. It means what? At every 100 feet of duct length, the friction loss value which we have to consider is how much? 0.1 inch of water column. But remember, this value will be vary as per for which application you are using this method, because we have a residential, a commercial, industrial application. So let's say generally the equal friction method is commonly used for residential and a commercial application. First, remember in your mind where we have to use the equal friction method for duct designing. Okay. So where now it is clear where we have to use the equal friction method. It is generally used for residential and commercial applications. So let's say if in this type of building you have installed the duct air handling unit and you want to distribute the condition air to the multiples room. So the methods which we have to use for duct sizing is equal friction method. Okay. So they have written clear here. So it is also used where duct sizing length. See the important point where we have to use this method, where the duct sizing length is a medium side, not large side. Because in industrial application, the duct which we are using, so it is a large sized. So here, where the duct sizing length is a medium size, not large size. Okay. So remember for residential and commercial application, generally we have to use the equal friction method. Okay. Now the question is here, sir, how much friction rate value we have to consider? So that I will explain you. We have a different as per SMACNA. If you follow the SMACNA standard, means SMACNA stand for Sheet Metal Air Conditioning Contractor National Association. So as per SMACNA, typically recommends a friction loss value of 0.1 inch of water column per 100 feet of duct length, which is near about 0.82 Pascal per meter. Clear this thing? Tell me. So this is this whatever it is given here. The SMACNA typical recommendation is given here that much. Okay. Now here this value is widely used in the industry, as I told you, na, and provide a balance between energy efficiency and duct size. But next, if you follow the ASHRAE guideline, so in ASHRAE guideline, it is given ASHRAE, all of you know, I think, American Society of Heating, Refrigeration, and Air Conditioning Engineers. It is a global society. Okay. So as per ASHRAE guideline, suggest maintaining a friction loss of 0.1 inch of water column per 100 feet of duct length as a common starting point. Here also they are suggesting same. Okay. See, someone asked telling me to show the previous slide. So see all of you, this is our previous slide as per SMACNA recommendation. Okay. Now let's see as per ASHRAE, as I told you, same thing. So however, ASHRAE allow for some flexibility depending on the specific application and design requirement. So for example, here is given in case where noise control is critical. So a lower friction loss also you have to maintain. Okay. So let's say, for example, if you are designing for any, that I will explain you ducts. So that is why I'm telling, don't be just be patient. Everything we'll discuss. Okay. You are talking about what is maximum duct size we can go for this. It is not depend. You can not ask like this. Okay. Actually, based on the different application, we have to select the different method that I will explain you. Don't worry. I will take one example and show you everything. So here what ASHRAE, as per ASHRAE guideline, remember where the noise control is critical. So you have to a lower friction loss value also you can maintain, like example 0.08 inch of water per 100 feet of duct length might be used to reduce airflow velocity and noise. Let's say you're designing for residential application or you are designing for any duplex apartment. So better is to prefer this one. Okay. Now, as per another methods are also there, like as per carrier design guideline. Uh, So carrier design guidelines are generally aligned with SMACNA and ASHRAE. Same. Carrier often recommend a friction loss of 0.1 inch of water per 100 feet of duct. Okay. For standard application. Now, maybe you are confused that, okay, as per ASHRAE also 0.1 we have seen. So here best is what? See, here I have taken one table. In this table, it is clearly written. If you are going for residential, if you are doing the duct sizing for residential application, so better is to maintain the friction loss value between this range, 0.05 to 0.08 inch of water column per 100 feet of duct length. Okay. If you are designing for commercial application, for doing the duct sizing for commercial applications, so how much? Always remember the friction loss value which we have to take is between 0.08 to 0.1 inch of water column per 100 feet of duct length. Okay. For industrial application, the range is given 0.12. You can go up to 0.15 inch of water column per 100 feet of duct length. Clear this thing? Tell me, please. All of you clear or not? Please give me answer, reply in chat box. Okay. So now I will take one example. So you will easily understood how we have to do the duct sizing by using equal friction methods. Okay. So let's see one example. Okay. So here I will use the MacWay duct sizer software. All of you know we have a different software. So here in one example I have taken, suppose we have a ceiling suspended AHU here and the application is, let's say, cafeteria. Okay. So tell me, cafeteria falls under which category? Residential, commercial, or industry? Tell me fast. Give me reply. cafeteria will comes under falls under which category? Residential, commercial, and commercial. Yes, everyone are right. Okay, so cafeteria. So suppose here we are doing the duct sizing for commercial application. Okay, so this is our ceiling suspended AHU. Suppose we have done the heat load calculation, because you know that first of all, what we have to do to find out the ton of refrigeration or to find out the cooling load value or supply air CFM value, first we have to do the heat load calculation. So for that, we have a different method. Okay, by using E20 method, you can perform the heat load calculation by using HAP software. Trace softwares are also there. Okay, and you can use the O general methods. They are using their own methods to find out the heat load calculation. So different methods are there. Even you can also use the thumb rule. Okay, so here, suppose from the heat load calculation, we have got, suppose here we need to supply 1200 CFM air into the cafeteria. Okay. So what I have done here, suppose I have done the selection. First, we have to do the selection of air terminals. So here we have decided to place 6 number of diffusers, supply air diffuser. And total how much air we need to supply? Tell me. In complete cafeteria, we have decided to place the 6 number of diffusers, supply air diffuser I'm talking about. Okay. So total air which we need to supply from this ceiling suspended AHU is 1200 CFM. So can you tell me if I'm using 6 number of ceiling diffuser? So from each diffuser, how much amount of air we are supplying in cafeteria? 200 CFM. Yes. And what are other students are doing? Only 3-4 students are giving me reply. Okay. Please be active, all of you. So you will take the interest, so you will get the knowledge. Okay. Okay. So here total 1200. So in this main line, main duct, you can say 1200 CFM we are distributing, and in each and every diffuser, we have to distribute the 200 CFM air. So first we are starting from the main duct. So let's see. Here we know that we are designing for commercial application. So which method we have to use for duct designing? Equal friction method. Okay. So in equal friction method, as I told you, at every 100 feet of duct length, we have to keep the friction value constant. Okay. So total CFM is 1200. Now we have to size the duct for 1200 CFM. So here, see, just open your MEP duct sizer software. So let me know, all of you, the software is visible. MEP duct sizer software is visible. Yes, please give me message in chat box. Yes, no. Okay. So this is your software. So how much CFM? 1200 CFM. So first thing here, what you have to do. In this, when you open the software, here you will get the flow rate. Here we are working in imperial units. Same way, if you want to change the unit as a metric, so okay, no problem. Come here in unit tab and change it as a metric. Okay, so in which unit you want to work, you can change it from here. So I'm using the IPS unit. Why? Because I want the flow rate value. I want to enter the flow rate value in CFM, cubic feet per minute. Okay, so just write down the flow rate value, 1200 CFM. Okay, here I have written the flow rate value. Now head loss. Tell me how much head loss we have to kept here at every feet, 100 feet of duct line. How much head loss we have to take for commercial application? I have shown you the ranges from 0.08. No, 0.1 is the maximum. 0.1 is the maximum, na? Range is minimum 0.08 and maximum 0.1. Okay. So here I am just using 0.08 minimum. Because problem is what? If you increase the head loss, automatically the velocity will increase. So only here in this software, you have to enter the 2 parameter, only the flow rate and head loss. Suppose head loss, I am taking 0.08. Automatically, when you enter this 2 parameter, you will get the velocity. See, near about 910 FPM, feet per minute. And see, the equivalent diameter is also showing 15.5 inch. Means if you are going for circular duct, round duct, suppose, so you have to use the diameter of duct 15.5 inch. Okay. So that you will get here. But here, I will show you the rectangular duct size. Okay. So in rectangular duct sizing, you have to remember one more thing. Aspect ratio is very important. Always we have to satisfy the aspect ratio. Now the question is, what is aspect ratio? Aspect ratio is what? It is the ratio of longer side of duct by shorter size. It is the ratio of longer side of duct to the shorter side. Okay. For example, in case of rectangle duct, all of you know, always the width of duct is greater than height. Okay. That is why we are using to reduce the height by increasing the width. Okay. So you can say like this also, width of duct divide the ratio of width of duct to the height of duct. Okay. Width of duct divide by height of duct. This is your aspect ratio. So remember, always the aspect ratio value should be greater and equal to 1 and less than equal to 4. Always you have to maintain the aspect ratio between 1 to 4. So to calculate the aspect ratio, as I told you, longer side by shorter side of duct. Okay, so let's say if I told you, for example, suppose the width of duct is just example. Okay, if I told you, suppose the width of duct is 500 and the height of duct, rectangular duct, is just take 200. So can you tell me, just calculate and let me know what is the aspect ratio? Please, all of you, if your duct width is 500 mm, in mm I'm talking about, okay, millimeter. Suppose here, see all of you the example. Suppose the duct width is given, uh, simple, suppose 500 mm, okay, millimeter. And your duct height is coming, suppose 200 mm. If I told you to find out the aspect ratio, so simple, as I told you, aspect ratio is what? Aspect ratio is the ratio of longer side of duct to the shorter side. So 500 divided by 200 is how much? Anyone? Give me reply. 2.5. Yes, all of you are right. So can you tell me, can we select this size of duct? 2.5 aspect. And as I told you, aspect ratio value should always be greater and equal to 1. Okay. And less than equal to 4. Aspect ratio value should always be greater and equal to 1 and less than equal to 4. Okay, between 1 to 4. So here in this condition, see the aspect ratio is coming 2.5. It means the size which you are selecting here, it is within limit. Okay, so you can select this side. But here in our case, remember the case is different here. As per, see, here I have opened the duct sizes software and now you have to tell me. Here we have entered the flow rate and head loss value. As per that, we have got the velocity and equivalent diameter. Now, you can see in the next column, the next one is the duct size, first and second. So in the first column, always you have to enter the height of duct, whatever height. So height is depend on the space availability. Na? Am I right? Tell me, please. Height is always depend on space availability. How much space is available above the false ceiling? As per that, you have to decide the height. So let's say in my case, what I am doing, I'm assuming, suppose this is one room. All of you just listen carefully, okay? What I'm doing here, I'm assuming, suppose here we have one room. I'm drawing the section of that room. Suppose this is my room, cafeteria, for example, okay? And here we have a false ceiling like this. Okay, this is a FFL, finished floor level, false ceiling level, and slab. So suppose the height available here to run the duct work is around 400 mm. Height is given by the architect site. Okay, now in this height only we have to, yeah, my screen is not visible, this PPT. All of you, tell me. Please give me reply. Now it is visible or not? Now visible, na? Okay. So what I'm doing here, suppose we have cafeteria, simple. Here inside the cafeteria, we have a false ceiling. So suppose the height above the false ceiling up to slab level, which is available, is 400 mm. And in this space only, we have to run the duct. So as I told you, the minimum gap minimum clearance, minimum space which you have to maintain from the false ceiling to ductwork after the placement of insulation and everything is how much? 100 minimum gap we have to maintain, okay, from the slab, from the ceiling. So let's say I'm assuming the duct height 300. In this case, 300 duct height we are considering. Okay, so that is enough now, because if you are running 300 height, so 50 here, 50 from slab. Okay, so 300 is best. So we are taking 300. So open the software and let's see. So just in the first box, write down the height, whatever as per space availability. So when, sorry, in inches, here you have to write down in inches. So I want to enter the value in millimeter. So you can change the unit, no problem. Or otherwise you want to work in IPS, okay, you can write down the value in inches also, no problem. So hit on metric. Now I'm writing the height 300. So when I have written the height 300, can you see the width? Automatically you will get the width 450. Okay. When here I have insert, tell me please fast, all of you. Please, here I have taken the height 300. So how much width we have got here? Yes, 450. Okay. So tell me now, in a rectangle duct, always we have to see the aspect ratio. We have to satisfy the aspect ratio as I told you. So can you tell me, calculate the aspect ratio and tell me the value of aspect ratio, how much we are getting? As I told you, aspect ratio, to calculate the aspect ratio, longer side of duct by shorter size, 450 by 300. So you will get near about 1.5. Okay. So the limit, can we select this size of duct or not? Yes, we can select, because aspect ratio should always be between 1 to 4 ratio. Na? So here our 1.5 is coming, no problem. We are in limit. Also, so we can select this size of that. Even if you want to select some other size, okay, that also you can use. Suppose, let's say if I'm using the height 250, let's say I have only space availability 250. That height I have taken 250. As per that, the width is showing 550. So when you calculate the aspect ratio for this size, 550 divided by 250. So how much we get? 2.2. So can we select this size of duct? Yes, because the aspect ratio is satisfying. No, here let me select. So here we have not considered the insulation. Remember, insulation in duct sizing, we don't need to consider the insulation. Okay, that is why I have taken 300 duct height, because we have 400 height, complete height is available. So suppose 100 you are just, I have just taken wrong here. Just see, actually problem here, just I am showing for example. Suppose, let's say, assume we have 600 or any other gap space is available here. Okay, 600 consider as a 600 So minimum, you know that from ceiling we have to maintain minimum clearance 100 From slab also we have to maintain minimum 100 Suppose 25 insulation from both sides. So how much? 250 means only we have 350 millimeter space available to run the duct. Okay, above the false ceiling. So here we have decided to take 300 height only. Okay. Now understood? Tell me, please, all of you. Limi, are you understood this thing now? Clear this one? Okay. So now here, let's see the size. So you can also select, if you are using 300 height, okay, as per that, whatever size you are getting, okay. If let's say if you're going for 250 height, so the width is coming 550. When you calculate the aspect ratio, you will get near about 2.5 something, na, I think. So what is whatever size, so that is also, you can also consider that size, because aspect ratio is satisfying. I have told you aspect ratio should always be between 1 to 4. Okay. Even now I'm reducing. Suppose when I'm going for 200 height. So see here the duct size which we have got is how much? 725. So can you tell me the aspect ratio value? So never take 725 as a width, because remember, duct fabricator manufacture the duct of some standard size. Okay. What are the standard size like 200 mm, 300 mm width of duct, 400, 500 mm, 600, 700 mm, 750. 725 is non-standard size. So better is to always remember whenever you will get this type of value 725 or 525 or 325, consider as a 750. Okay. Because as I told you, a fabricator will manufacture some standard size of that. So go for 750. 750 divided by 200 is how much? 3.75. Okay. It means here also the condition is satisfying. You can select this size. But the problem is what? Always remember, based on the height available, as per that you have to select the size. So right now, as I told you in our case, how much height we are taking? 300. So for 300, how much height width we have got? Tell me, please. Better is to maintain the aspect ratio near the one value, okay? Near the one. So, okay, 450. So same way when you see here, in our case, here we have got the size 450 mm by 300 mm, okay? So just write down that value. Clear? So here I have done the main duct sizing. Tell me please, all of you, is it clear? This value is clear from where we have got, okay? So it is very easy. Just you have to understood. So it is very easy. Now, next thing. So this is for 1200 CFM. We have got the duct sizing, and always remember, always try to maintain the constant height in the main duct. If aspect ratio is satisfying is okay. Other sometime, let's say, if you're maintaining the constant height in the main duct, but problem is what? During the duct sizing, maybe the aspect ratio is not satisfied. So on that time, we have to reduce the height, no problem. But always try to maintain the constant height into the main duct. Okay. So let's say 1200 CFM in the main duct we are supplying, 200 CFM we are supplying in this diffuser, 200 in this diffuser. Now the remaining CFM is how much? Tell me. Because from each diffuser we are supplying 200, remaining is 800 CFM. Now for 800 CFM we have to do the duct sizing. As I told you, always try to maintain the constant height in the main duct. So 300 mm we are maintaining. Okay, so simple. Now open the duct sizer and let's see for 800 CFM how much duct size we got. First, just change the unit as a IPS. Okay, and here now I am writing 800 CFM. And head loss I am just considering same because I have told you in equal friction method always at every 100 feet of duct end we have to cap the friction loss or head loss value constant. So here same value I have written. As per that, you can change the unit. See, duct size is given in inches also, but here we have to write in millimeters. So, okay, change as a metric. See, when I'm considering 300 height, so how much duct size is width of duct is showing 350. So can tell me the aspect ratio is satisfying for this size or not? Yes, of course. So can we select this size of duct? Yeah. So here, but remember one more thing which I have already explained you, that always don't take any non-standard value. As I told you, not fabricator will always manufacture the duct size, some standard size of duct like 300, 200 mm, 350, 400 mm. Okay, so just don't need to take this non-standard value. So better is to take 350 mm width. Okay, and height is 300. So as per that, you have to write down the size here. Okay, so see, for 800 CFM, how much size we always write in this sizing when you are writing in AutoCAD file. So always remember, first of all, always we have to write down the larger size. Okay, and then it will represent that 350 is your width and 300 is height. Okay, so 350 by 300. Now, when you are supplying 200 CFM in this diffuser, 200 here, now the remaining CFM is how much in the main duct? 400. Okay, remaining CFM is 400. So we have to do the sizing for 400 CFM. Okay, so again here I have opened the duct sizer software. Now just 400 CFM I have run, and head loss I am maintaining same constant. Okay, so as per that, when you change the unit as a metric, see now when I am using the height 300, see the width we are getting 200. So the aspect ratio is satisfying in this condition. I'm assuming the second column is width. Okay. So in this case, aspect ratio is satisfied. No, 300 by 200 is how much? Is near about, sorry, 200 by 300 is how much? 0.66. So the value, aspect ratio value is coming less than 1. So always we have to maintain the aspect ratio value between 1 to 4. Okay. So here, now if we are maintaining the constant height in the main duct, problem is what? Aspect ratio is not satisfying. So okay, no problem. Now you can reduce the height to maintain the aspect ratio. So now I'm just using 250 height. So when I'm going for 250, see the width is also coming 250 near about. So okay, no problem. Just go for that. Otherwise, you can also take the height as a 200 mm. Okay. So here for 400 in this branch, the size we have got 250 by 250 mm. Is it clear? Aspect ratio is also satisfying 1. Okay. Minimum should be 1 or greater than 4. Okay. You have to take. So here we have calculated the duct size in the main duct. Now we have to do the calculation for branch duct. See, here we have taken the branch duct na, to connect the diffuse, and in this branch only we have connected the diffuser. So for each and every branch, we are supplying 200 CFM. So we have to do the duct sizing, branch duct sizing for 200 CFM. But the one thing which you have to remember here, sorry, all of you, suppose if in the main duct, what height we have taken, main duct height, 300 mm. So always for branch duct, don't need to take the same height for branch duct. But because suppose let's say if you have taken 300 height for branch duct also, so how it is possible to fabricate inside? Okay, it is not possible. Here shoe necks, other, okay. So it is not possible inside. So always remember in branch duct, when you are doing the duct sizing for branch duct, the height of branch duct should always be less than the height which you have taken in the main duct. Suppose in the main duct, if you have taken 300 mm height, so in branch duct, try to take 250 height. Okay. If aspect ratio is satisfied, is okay. But here when you see, here we have reduces the height also. In this case, in main duct, 250. So better is what? In branch duct, how much height? Better is to maintain the 200 mm height in branch duct. Okay. Always less than the whatever height you are maintaining in main duct. Okay. So let's see now. Simple. Here I have opened the duct sizes software. Let's see, change the unit as a IPS. And now I'm writing the flow value in CFM 200. Head loss I have taken same 0.08 inch of water column per 100 feet of duct length. And I'm changing the unit as a metric. Now, when I'm selecting 250, suppose let's say, for example, in branch duct height, when I'm selecting 250, width is showing 150. So here, aspect ratio is not satisfying. So it means you have to reduce the height. So now I'm reducing 200. So when I'm taking 200 height, so the width of duct is also near about 200 only, na? Because I have told you some standard size of duct is there. If it is coming 175, you have to assume as a 200 mm. Okay. So here we have got 200 by 200. So can we select this size of for branch duct? Tell me. And you have to see the height. Okay. How much minimum height you have taken in the main duct? 250. So always in the branch duct, for branch duct height should always be less than 250. So in our case, we are using 200. Okay, no problem. Okay. So for each and every branch duct size, we have got 250 by, 200 by 200 or 200 by 150 also. It is depend on you. So here I have written 200 by 150. Why? The reason is what? See, I will show you. Actually, here, if I'm using, see, try to understand this concept also. If I'm using here 200 height, suppose I'm selecting 200 height. So width also I'm getting near about 200. But when you change unit as a C, but in this case, problem is what? Na? There is no problem. You can select this size also. But if I'm just going for 150, let's say 150. Width is coming near about 200 or 250. It is depend on you what standard size. Now here I want to show you, suppose here the velocity is showing 581 FPM. Okay, see the velocity 581 for this size. Now when I'm changing as a 200 height for this size, change and see the velocity 581 only. Okay, so you can select any of this size, no problem. It is depend on you. You can go for 200 by 200 also, or if you are interested for 150 by 200 or 200, okay, that size also you can take. So both is applicable here. Okay. So here in this PPT, the size which we have taken for this 200 CFM in branch, width is 200, height 150 mm. Okay. So in this way, you have to do the duct sizing by using equal friction method. But remember the one thing where we have to use the equal friction method for residential and commercial application. Okay. This is our equal friction method. I hope all of you clear this concept. Tell me. Someone is asking me how to calculate the number of diffusers. So this, remember here, the webinar is on duct designing method. Okay. We are not just giving you the complete HVAC knowledge here. Okay. So for that, we have a separate topic, separate webinar, diffuser selection. Okay. We have a different software, different catalog. Okay. Sarovar, is it clear? Actually, here I want to show you only the duct designing method, duct sizing method. Okay, I'm not going for diffuser selection. So remember, because we do not have that much of time here. Okay. So this is our equal friction method. Now come to next method. Next is what? Here I have taken small example so you can easily understand. Okay. Next is the velocity reduction method. Okay. Now let's see. Huh. Someone is telling me, and if is more than 100 feet in duct commercial, I'm not getting this, what you're trying to ask. Okay. In equal friction method, always remember you have to keep the friction constant at every 100 feet of duct length. Okay. This is the method. Yeah, of course. Yes, you're right, Samim. You're right. Actually, branch duct size now, always remember all of you. Someone is asking me that we need to size the branch duct based on diffuser neck size. Yes. All of you remember in diffuser, generally we have a face size. From the top view, when you see in the AutoCAD file or wherever here also, in the catalog, when you do the diffuser sizing, always you will get the neck size in catalog or in any software you are using for diffuser selection, diffuser sizing. So always in the catalog or in the software, the size which is written, it is the neck size of diffuser. Face size should be vary as per manufacturer to manufacturer. Let's say as per GGC, Gulf Grill Corporation. As per GGC, face size of duct should always be 1.5 times to 2 times greater than neck size. Okay, for example, I will show you so you will get the idea. So let's say all of you here. So first let me know my blackboard is visible for all of you so we can start. See, here I'm showing you. Okay, see, suppose this is your diffuser. I'm drawing the section view of diffuser. Okay. Diffuser will look like this only, na? Oh, sorry. Actually, this is not a topic, but then also see. Okay. This is your diffuser. Okay. When you see the diffuser from front side, it will look like this only. Am I right? Tell me. Okay. So this is your neck of diffuser, neck side. Okay. And here, which is the diffuser, which is exposed to the room. This is your face side. Okay. In neck, always the duct is connected in the neck only, neck of diffuser. And from here, we are supplying conditioning. This face is always exposed to the room. Na? So here, remember, neck size you will get from the catalog, different catalog software, but face size will be vary. Okay. So as per GGC, when you prefer, means Gulf Grill Corporation. So as per that, always the face size of duct or diffuser should always be 1.5 to 2 times greater than neck size. Okay. Let's say from catalog, the diffuser size you have got 300 mm. 300 mm by 300 mm. This is your neck size from the catalog. So if I told you, tell me the face size. So face size should be, if you are using 1.5 or 2 times greater, so 600 by 600. This is your face size. But remember, face size will be vary as per manufacturer to manufacturer. Here I have given you the idea as per GGC, it is 1.5 to 2 times greater than neck size. Okay, all of you understood? So sometime the branch duct size we have to do as per neck size. Suppose if your neck size of diffuser is 300 by 300, as per that, and sometimes we are using flexible duct, all of you know that. Okay, so it is depend on that. We have to do the sizing. Now let's see the next method of duct designing. All of you clear up to here? Huh. Some plenum box to be installed with VCD. Yeah, of course, plenum box also we are installing sometime in diffuser. Actually, the use of plenum box, the purpose of plenum box is what? To convert the turbulent flow into laminar flow, na? To reduce the noise. Generally, we are using. So everywhere we are not using a diffuser with plenum box. In that area where the noise is concerned, okay, where we have like you are designing for hospital building, okay, where we have to reduce the noise level. So better is to go for plenum. Use the diffuser with plenum box. So for that we have a complete designing. Okay. Actually, here the webinar is on duct designing. That is why I'm not going in depth because here we have only 3.5 hours to discuss this each and every method. So that is why I'm not going in detail. But if you want to know everything in detail, because this is only the one topic. Here I am discussing only the one topic of HVAC designing. Okay, duct designing method. If you want in-depth knowledge, the complete HVAC designing knowledge or complete MEP knowledge, so you have to join with us in live classes. So I will give you the short review what actually we are teaching in live classes. Okay, so already we have scheduled a complete postgraduate program. So can you tell me this my PDF file is visible, all of you? We have scheduled a complete postgraduate program in MEP designing and drafting. So here in this program, generally we are teaching each and every services, either it is a HVAC, plumbing, firefighting, electrical, designing also, and in drafting also we are teaching in detail. Here we have taken one live hospital building. In that hospital building, I will show you how to run the HVAC services, plumbing, like if you're just like you are working practically in industry, in company, same that knowledge we providing here in this. So here some quick uh, program highlight is given. Here we have a complete live class for 6 months. Okay, near about 200 hours. Remember, the class will be on only in weekend. We have a 2 class. Okay, on Friday or in Sunday. One class we have in Friday in week and on Sunday. Only 2 day we have class in weekend, and the duration is around 4 hours. Okay, you will get the access to recording for 1000 day. Even here in this program, we are using 12 plus MEP software, like in firefighting services, we are using a light software, in HVAC, like duct designer, duct sizing software, air terminal sizing, diffuser sizing software, many other software. Okay, duct fitting, chill water piping software, many software, 12 plus MEP softwares are there, which will give you, you can easily download that software, and will give you the access to class note, whatever PPT which I'm showing you in the live class. So you will get the access of PVT for 1000 day. Even will also give you the 500 plus interview practice question. So you can easily crack the interview also. Okay. And 100 plus file to download, a handbook, whatever data, catalog, Excel sheet, whatever I'm using in the live class, all data will share with you. You can easily download that all. Okay. Then internship and job assistance are also there. After that, you will get the certificate of completion. Okay. So in this complete postgraduate program, here the syllabus is also given in detail. So here I do not have that much of time to show you the syllabus and everything. Okay. Here, see, quick review is given: AutoCAD drafting, then HVAC designing, 56 hours, near about plumbing designing, 24 hours, means more than 24 hours, 40 hours, firefighting designing, electrical, 24 hours, then MEP drafting, near about 50 hours. Okay, we have a separate. First, So here the syllabus of AutoCAD is given. Everything is given. We'll share with you. Okay, so don't worry about that. So this is our complete postgraduate program. So if anyone are interested to join with us in live class, so okay, no problem. You can visit our website, or I will share you the number also, WhatsApp number in the end of the class. You can contact to that number. So for more access, for more detail, if you want more detail about this complete program, we'll share you. So if you want more detail, in the end of the class, I will share everything. So don't worry about that. But in between the class, I will not share anything. Okay. So you have to join with us and from the up to end. Okay. So this is the quick review of our program, and I am only trainer of this. So each and everything, after the completion of this course, now you are become a, you can anything, you will get the project. So you are able to design MEP services easily. Okay, so let's see, come to our main topic, which we have to discuss here. Okay, we have discussed the equal friction method. All of you clear this thing? Next thing, next method is velocity reduction method. So what is this? See, this method size the duct by varying the velocity, okay, in the main and branch duct. So here the velocity will vary. So this method focuses on gradually reducing the air velocity as it moves through the ductwork. This method is useful for reducing noise and maintaining comfort level in spaces. So where we have to use, where the noise is in concern. Okay. If you want to reduce the noise. Okay. So in that, for that application, generally we are using. So it is more expensive as compared to equal friction method, because here the duct size is as same CFM. I will show you as same CFM. In equal friction method for 1200 CFM air, how much duct size we have got? 450 by 300 mm. Na? Same when you use the velocity reduction method, you will get size may be increased. So that is why velocity reduction method of duct sizing is more expensive as compared to equal friction method. But so that is why where we have to use this method, this is the question, where cost is not an issue. In that application, you have to use where cost is not an issue. Like, for example, if you are designing for duplex apartment, palace, luxury apartment, where cost is not an issue. So in that application, in that, you can use this velocity reduction method to control the noise level. Okay, clear? Because you know that in luxury apartment, there is no issue of cost. We can prefer the velocity reduction method. Clear this thing? Tell me, please, all of you, where we have to use the velocity reduction method. Is it clear? Okay. Now the question is, sir, how much velocity we have to maintain in the main duct, branch duct? So as per carrier design manual data, I will show you the velocity which we have to maintain. See the maximum duct velocity table. This is from carrier, as per carrier air system design manual. They have given the velocity range. Okay, here don't need to go for friction loss now. In equal friction method, we have to keep the friction constant at every 100 feet of. But here in velocity reduction method, now we have to focus on the velocity. Suppose let's say for residential application, in the main duct, for supply duct, how much velocity it is showing? Maximum you can maintain up to 1000 FPM velocity. In return duct, 800 FPM. Same way for branch duct, supply air duct are there. So velocity 600. For return air duct also same 600. But here see, in this column, controlling factor noise generation main duct is given 600. What is this? What is this? Anyone? Controlling factor, remember, as per this table, in the main duct, they have given for supply air duct, always maximum velocity which we have to maintain inside the duct in residential application is 1000 FPM. Minimum 600 FPM. Between this range, you can maintain. Okay, for better design. Same way, apartment, hotel bedroom, hospital bedroom, private offices, everything is there. So as per your application, suppose if you are designing for offices, you have to prefer in the main duct 2000, you can go up to 2000 because it is a commercial space. So no problem. If noise is little bit more, no problem. Commercial space, return duct, supply, return. So here the velocity range is given. Okay. Now I will take one example. So you will easily understand what is actually this velocity reduction method. So first, let me know all of you clear this thing? This table, as I told you, from carrier air system design manual we have taken. So here the velocity range is given. So this is clear. Understood, all of you? Okay. Okay. So now let's say example. All of you try to understand. Suppose here, say ceiling suspended issue. Now the application, suppose here we have to design the duct. Okay. We have to do the duct sizing for duplex apartment, deluxe apartment, let's say. So as I told you, where we have to use the velocity reduction method, where in that area where cost is not an issue. So let's say for deluxe apartment here in this luxury apartment, palace. So here the cost is not an issue. Okay. So no problem. You can go for velocity reduction. And here we have to maintain the noise level also. You have to reduce the noise level. So, okay, ceiling suspended AHU. Now the duct, same from the heat load calculation. We have done the calculation. As per that, we have got a 1200 CFM, let's say. In deluxe apartment, we need to supply total how much CFM air to maintain the comfort in environment? 1200 CFM, cubic feet per minute. Now, for same CFM, I'm doing the sizing. Okay, remember, in equal friction method, we have got how much? 450 by 300. Width of duct we have got for 1200 CFM, 450, height 300 we have taken. Suppose here also the space available above the false ceiling to run the duct work is 300 maximum. You can maintain up to 300. So no problem. First you have to see deluxe apartment will falls under which category? Residential, commercial or industrial? Let me know fast. Deluxe apartment will comes under which category? Yes, residential. So when you see here, I will show you. See, in this table, where it is, this one. 1 minute, I will take a screenshot of this. So, okay. Now let's see. 1 minute, all of you. Okay. Take the example. So 1200 CFM air, and here the number of diffuser which we have taken in this deluxe apartment. Same, suppose we have got 600. We have decided to place the 600 supply air ceiling diffuser. So if total airflow is 1200 CFM, so from each diffuser, tell me how much air we need to supply from each diffuser? 200 CFM, same. Okay. So from each diffuser, we have to supply the 200 CFM condition. So now, as you see here, this screenshot is visible, all of you. Let me know, please. This table is visible. So in this table, as I told you, that deluxe apartment falls under which category? Residential. Okay. It's a residential application. Here the apartment is given, but it is a normal apartment. Okay. Here we are designing deluxe apartment. So go for residential. In residential, let me know in the main duct for supply air duct, if you are doing the sizing for supply air duct, so how much maximum velocity we can maintain in supply air duct? 1000 FPM. Controlling factor is given here, 600. Okay. Don't between 600 to 1000 FPM you can maintain. Okay. To reduce the noise. Same way in branch duct, in supply air, 600 FPM. Okay. As per that, we have to design. So let's say now, here in our case, what I am doing, all of you try to understand. This is about 1200 CFM air. Now just open the duct sizer software. Now see how to do the duct sizing as per velocity reduction method. First, I am changing the unit from here IPS. Now just uncheck the head loss, because now don't need to enter the head loss value. Here now we have to enter what value? First flow rate value, just enter the flow rate value. How much? 1200 CFM. Now you have to enter the velocity. Don't need to enter the head loss. Head loss we have to use only for equal friction method. For velocity reduction method, here. Now all of you tell me, this is our main duct. In main duct, 1200 CFM is flowing. So velocity, how much maximum we can maintain? up to 1000 FPM, no problem. Minimum 600, okay, in the main duct. So suppose I'm maintaining average 800 FPM. If I'm maintaining, as per that, the head loss value which I have got here is how much? 0.058. If I am maintaining 800 FPM, head loss, how much we have got? 0.058. And I have told you for residential application, I have shown you one table, if you remember in starting, when we are discussing about equal friction method. In that table, it is written clear, if you are doing the duct sizing for residential application, so the head loss range should be between 0.05 to 0.08. Am I right? 0.05 to 0.08. Na? In this range, you have to maintain the head loss. So, okay, no problem. 0.058 is coming, no problem. Because the value is between 0.05 to 0.08. Okay, it is clear. You can take the 800 FPM also. But let's say if you want to take 900, but when I'm taking 900, problem is what? Here the head loss is now increasing. When you increase the velocity, automatically the head loss will increase 0.078. Okay, you can do the duct sizing as per 900 FPM also, no problem. But when I'm going for 1000, let's say, see the head loss value is 0.1. So can we do the sizing? Can we design the duct as per this 1000 FPM? Because head loss value is coming 0.1 inch of water column. And I have told you for commercial space, you can maintain the head loss up to 0.1. So remember, in this way, you have to see, you have to analyze that when we are going for 1000. Okay, in that table, it is given, okay, you can go up to maximum 1000. But remember, you have to check the head loss also. If head loss is going more than 0.08 for residential application, don't need to select that velocity. So here, right now, I'm going for 800 only. Okay, suppose 800 I have selected. Now change the unit. Now, suppose the height of duct I'm taking 300. So as per that, see the width we have got how much? 500. That is why I'm telling the velocity reduction method of duct sizing is more expensive as compared to equal friction method, because for same CFM, you can see here the width of duct is more, as I have shown you in equal friction method. In equal friction method, we have got 450 by 300, but in velocity reduction method, 500 by 300. So when the duct will increase, so automatically the cost will also increase. Na? So that is why it is more expensive. Is it clear now? Understood? So can we select this size 500 by 300? You have to check the aspect ratio first. 500 divided by 300. So it is near about 1 point something, 1.6. So aspect ratio is coming between 1 to 4. It means it is satisfying. So for 1200 CFM air, we have got the duct size. How much? Tell me fast. Yes. See? So here I have written 500 by 300. Okay. In this main duct, 1200 CFM, 500 width, 300 height. Now come to for this 800 CFM, because 200 CFM if you are supplying here, 200 here. So remaining is 800. So for 800 CFM, we have to do the duct sizing. So same condition is same. Just open the duct sizer software. Okay. This is your software. Change the unit first. If you want to work in imperial, okay, no problem. You can write down the value in inches. Actually, in my PPT, I have written the sizing in mm. That is why I'm changing the unit. Okay. So now I'm writing the flow 800 FPM and velocity now. You know that in velocity reduction method, when you go far away from AHU, so automatically the velocity will reduce. Na? So when I'm taking 800 in the main duct, see the head loss is near about 0.074. So better is to just reduce it little bit, make it between, because remember for 1200 CFM, head loss is showing 0.058 for 800. Now you have to reduce the velocity little bit. Okay. Suppose let's say I have reduced 700 FPM. Now I am taking. So for 700 FPM, now you have to check the head loss, because head loss should always between how much range? 0.05 to 0.08. Okay, so here also it is clear. So now change the unit, and for 300, see 375 they are showing. Okay, so no problem. You can If you want, you can go for, I think 750 also. The range is same only. Okay. So as per that, you will get the size 300 by 350 width. Or so same, you can see in PPT, same size is written. Tell me, am I right? Please give me answer. So all of you clear? If anyone have doubt, so please let me know. So I will solve that problem. Clear, understood this thing? Okay. So my screen is visible first. Oh, 1 minute, huh? So I hope that all of you, all of you are understanding this thing. Okay. It is very easy. That is why I have taken a simple example. Okay. Now tell me, here for 800 CFM, the size which we have got is 350 by 300. Okay, so I have written here. Same way, now when you go for next branch, means next section of that, like when you are supplying 200 CFM here, now the remaining is 400 CFM. Okay, so for 400 CFM, we have to do the duct sizing. Okay, so let's see now. Change the unit first and write down 400 CFM. And you have to reduce the velocity because when you are going for so velocity will reduce now again. So when 750 I'm taking, see the head loss is coming more than 0.08. It means we have to reduce the value. Okay. When I'm selecting 700, then also see problem is what? Head loss is greater than 0.08. And we know that for residential application, maximum how much head loss we have to maintain? Tell me fast, all of you. 0. No, max velocity I'm not talking about. Okay, velocity we can maintain up to 1000, no problem. But we have to see the head loss also, na? That also you have to see, okay? So then also it is coming more than, so better is to go for 650. So when I'm taking 650 FPM velocity, now the head loss is less than, okay. So now you can change the unit and do the duct sizing. But let's say, as I told you, in the main duct, always try to maintain the constant height. But here, if I am taking the duct height 300, width is coming less than that. So it means the aspect ratio is less than 1. So aspect ratio is not satisfying. So if you are facing this type of problem when aspect ratio will not satisfy, so now you have to reduce the height. Okay, you can go for 250. You can select this size of duct also 250 by 250 because here the aspect ratio is satisfied. If let's say you want to go for 200, okay, 200 by 300 means 300 width, height 200. You can select this size of duct also. Clear now? Same way you have to do for branch duct. Clear? So suppose the branch duct size we have got 150 height and 250 width. All of you let me know fast. Is it clear up to here? Anyone have doubt? So you can ask me. So you have 2 minutes to clear your doubt. Up to here, anyone have any doubt in any point which you have not understood for duct sizing. So you can, without any hesitation, just give the message in chat box. I will solve that problem. Okay. Someone is asking me what is the smallest duct size? Yes, very good. So remember always the height, the minimum height which we have to consider in case of rectangle duct, the minimum height of duct should not be less than 4 inch, 100 mm means should not be less than 100 mm. Okay, this thing you have to remember. But then also we are not taking 100 mm also. But let's say in any situation, if you want, if you have height up little bit space also you have, okay, you want to run the duct in that space. So minimum as per standard is 100 mm minimum height. Okay. Sayyid Saad Ali, is it clear now? This thing, how much minimum height we have to consider for duct? Okay. Don't go less than 100 mm, means near about 4 inch. So, okay. So this is our equal friction method and velocity reduction method. Now the third method, which is very interesting, is static regain method, where we have to use that method and how to, because static regain method is a longer procedure. Okay. So it is called as a hit and trial method. Okay. That I will explain you. Someone is there, what about length of the duct? Remember the length of the duct is depend on your velocity or which method you are preferring. Na? I have told you if you are going for velocity reduction method, we can't say like this, how much maximum length we have to maintain. Okay. So you have to see the velocity as per that. Uh, it is enough is okay. As per that, we have to select the duct length. Okay, because when you fabricate the duct, we have some standard length of duct, you know that. Okay. So right now we have completed two methods of duct sizing, equal friction, velocity reduction. Now we have to discuss the static regain method. Okay, very interesting method. So that we have to discuss. But before that, all of you just take a break of 10 minutes. Okay, just take a break of 10-15 minutes. After that, we'll continue. Right now it is 8:20. All of you join after 8:35. Okay, Indian timing, 8:20 p.m. Right now it is. Take a break of 15 minutes. Okay, 15 minutes. And join at 8:35 p.m. exact. Okay, IST. Clear? So if anyone wants to drink the water, they can drink it or take a break for if you want to rest. Okay. So I'm just writing here also. Take a break of 15 minutes. And at what time you have to join? Joined at 8:35 p.m. IST. Okay. Clear? Tell me, give me message, yes or no. You have understood, all of you? Okay, Rizwanullah, you are joined very late. So can I have recorded video? In starting only, Rizwan, I have told everyone that we are not providing any recording for this webinar. Okay. So whenever you have joined now, just see that. Okay. Just stay with us till the end. I will explain you each and everything. Okay. Because some special offers, some special discounts, some special offers are also there, which I want to announce in the end of the class. So all of you joined at time. Okay. Okay. So now all of you, please give me answer. Am I audible clearly? Yes. All of you are there. Just give me an answer. Okay. Yes, no. Am I audible? Okay. So let's see now. As I told you, we have discussed that all method. Okay, equal friction and velocity reduction. Now we have to start the next method of duct sizing. What are that? The static regain method. Okay, this method is generally used for industrial application where we have a long duct routine and where we need high airflow with high pressure. Okay, so in that area, generally in industrial application, we are using where the duct routine is long. Okay. So what is this? First, try to understand. What is equal friction method? Oh, sorry, static regain method. Here they have given. See, static regain is what? It is the process of converting velocity pressure to static pressure. All of you know, in starting only, I have explained you what is a static pressure. Okay, static pressure is the pressure exerted by the air in the duct system when it is not in motion. And velocity pressure is the pressure exerted by the air in the duct system when is in motion, when the air is in motion, okay, through its velocity. So yes, static regain is the process of converting velocity pressure to static pressure. Static regain methods of duct sizing is based on Bernoulli's equation, which states that when a reduction of velocity takes place, a conversion of velocity pressure into static pressure occurs. Yes. So with this method, the duct velocity are systematically reduced over the length of the distribution layout, which allow the velocity pressure to convert to static pressure. Okay, so this means there is the same static pressure near all the branches and all the diffuser, and therefore the system design required little or no balancing. So this is a complicated process. Here the duct designing is very complicated because it is a heat and trial method that I will explain. And where we have to use the static, generally this method is used for industrial application where the duct route is long. Okay. So now see for that, it is written here, everything. Okay, what I have explained. Here you have to remember the one thing. If the duct route is long duct, because in industrial application, all of you know, we have a long duct routing. So we know that when you are supplying conditioner through AHU or through FCU, whatever AHU, so automatically what happen? The gradually the velocity will reduce. Okay, so it is written clear here. What point is written that when a reduction of velocity take place, a conversion of velocity pressure into static pressure occurs. So how to use the duct, how we can use this static regain method for duct sizing, that I will explain you. So same, here one example, you have to remember some calculation here. How to calculate the static pressure. So for that, here formula is there. SP is static pressure is equal to capital R in bracket V1 by 4000 square of V1 by 4000 minus square of V2 by 4000. What is this? V1 is the velocity at previous duct section. V2 is the velocity at current duct section. Okay. R is the recovery factor, depends on shape of fitting that changes velocity. So the ranges is given, our recovery factor values is given range between 0.7 to 0.9. That you will understood when we take the example. Okay. And next thing which you have to remember, the static pressure formula is clear. Next, always remember in a static regain method of duct sizing, you have to satisfy this condition. Always the friction loss value should always be less and equal to regain. Suppose the duct sizing, you have select the duct size, okay, as per whatever CFM. Now you have to check the friction loss value and static regain value, means static pressure value. So if your friction loss value is less and equal to static regain or static pressure, so it means the condition is satisfying. The size which you have selected, it is correct. Okay. Or the velocity which you are maintaining inside the duct, it is correct. If your losses, suppose the friction loss value is coming greater than static pressure value, so it means the velocity which we are maintaining inside the duct is not correct. Okay. So again, you have to reduce the velocity and check it. So that is why I'm telling in this method, the calculation is done by hit and trial method. Okay. So let's see the example so you will get the idea. So in this example, here I have taken industrial application. Suppose the floor mounted AHU we have considered here. With the help of ductwork, what we are doing, we are distributing the condition air in each and every diffuser. Suppose in this total, we have got 8000 CFM. Okay, from heat load calculation. First, all of you know that first we have to do the heat load calculation to find out the airflow rate, supply airflow. So 8000 CFM we have got. Okay, and here we have selected 8 number of diffuser, either circular, rectangle. So it is depend on you which type of diffuser you want. Square shape, circular, rectangle diffusers are available. Okay. So 8 number of diffuser if you are selecting in for this application. So you know that total CFM is 8000 CFM. So number of diffuser which we have selected is 8. So each diffuser CFM is how much? Simple, 1000 CFM. Na? From each diffuser, how much condition air, how much amount of condition air we need to supply? 1000 CFM air we need to supply. Okay. And see here, section A length is also given, duct length 45 feet. Section B length is also given 40 feet. Section C length 40 feet. Section D length is also given 35 feet. And each branch length is 15 feet. Okay. Now here I will use the Excel sheet in a static regain method for duct sizing by using. So just 1 minute, I will open that. So now tell me, this Excel sheet is visible, all of you? Please let me know. Please fast. This Excel sheet is visible now. Application is same, okay? As I told you, for industrial application, we are designing. So same, suppose from heat load calculation, 8,000 CFM we have got in the main duct. Then when you are supplying 1000 CFM in this diffuser, 1000. So remaining 6000. Again, when you are supplying 4000. So a section A flow rate is 8000 and total length of duct is 45. Okay, so remember this all detail. And now the next thing, for industrial application, first let me know for industrial application in the main duct, how much maximum velocity we can maintain. You can open the carrier as system manual and let's see, search it here. So in the last point, last row, you will get application industrial. See, in the main duct or supply air main duct, how much maximum velocity we can maintain here? Maximum we can go up to 3000 FPM, no problem. And in return air duct, 1800. Okay. Remember, for branch duct, maximum 2200. In return air duct, 1500. Okay. Is it clear this thing? Velocity range is clear or not? Fast, all of you. Let me know, please. Is it clear? In industrial application, how much maximum velocity in the main duct we have to maintain? Up to 3000. Okay. So no problem. So come here and let's see now in Excel sheet. So it will more clear. Okay. So now here same point is given. Same formula which I have already shown you. That formula is written here. See, to calculate the static pressure value, capital R is equal to V1 square of V1 by 4000 minus a square of V2 by 4000. V1 is the velocity at previous duct section. V2 is the velocity at current duct section and R is the recovery factor. So depend on shape of fitting that changes. So their range is given, changes velocity. The range is what? 0.5 to 0.9. Okay, that I will explain you later. So this method is used for, see it is written clear where we have to use the static regain method. This method is used for high velocity system with long duct run. Okay, so basically for industrial application. And it is more balanced system and does not require unnecessary damping. Procedure, first what we have to do? First, in first section duct size, have to know without, we have to know the first section duct size without static pressure. Okay, so let's see. For example, I'm going to start from here. What is our section number? First section, section A. So write down the name, section A. What is the CFM? Tell me fast. All of you, don't be keep quiet. In A section, CFM, how much? Yes. Please give me message in, okay, 8000 CFM. So I'm writing 8000. Okay, cubic feet per minute. Now the question is, okay, flow rate, we know the flow rate and length also. The section A total length of duct is 45 feet. Okay, so I have written here 45 feet. Now the other remaining value like velocity, friction, and a friction loss in inch of water gauge in 100 feet of duct length. So we know the velocity. We know the velocity in the main duct generally for industrial application. If you are using a static regain method, okay, so in main duct maximum we can maintain up to how much velocity? Yes, tell me. How much maximum velocity we can maintain? Up to 3000. So suppose let's say here from in the starting of the duct section, I'm maintaining 3000 FPM velocity. Okay, velocity I'm maintaining 3000. So if you know the flow rate and velocity, so other remaining value we can easily get from the duct sizer software or not, like static, friction value in water column per 100 feet of duct, automatically you will get. Okay, equivalent diameter also, rectangle duct size also you will get everything. So first we are doing the calculation for main duct. So in remark, I am writing main duct. Okay, now let's see. Open the duct sizer software. Simple, and try to understand all of you how we have to find out the size. First, I'm changing the unit as IPS. Now, flow rate is 8000. I have written. Now, velocity, we are maintaining 3000. So, okay. in the A section. So I have written 3000 velocity. In starting, we know that maximum 3000. But in next section, how much velocity we don't know. Na? So how you will get this idea? See, 8000, when we have selected 8000 and velocity 3000 FPM. So can you tell me the head loss value, how much we have got? 0.51 inch of water column per 100 feet of duct length and equivalent diameter 22.1. So I'm writing that in Excel sheet. Tell me fast. Equivalent diameter 22.1 inch. Friction. Yes. Head loss value how much? 0.51 feet of inch of water column per 100 feet of duct length. So remember the friction loss value which we have calculated 0.51 is for 100 feet of duct length. But in our case, how much total duct length we have in section A? Yes, let me know. We are not providing any recording, okay? So don't be asked for recording class. Let's see all of you. In friction, so total length of duct means the section A duct length is 45 feet. So friction loss in 100 feet of duct length is 0.51. So can you tell me what is the friction loss value in 45 feet of duct length? Is 0.23. Is it correct? Correct. See, I will show you easily. Simple calculation. Let's say what they are telling. Try to understand. Okay, all of you. They are telling that we have got where it is. 1 minute. See, in 100 feet of duct length, 100 feet of duct length, friction head loss value, how much we have calculated? Tell me fast. In 100 feet of duct length, how much head loss value we have calculated? 0.51. Na? So if for 100 feet of duct length, friction loss value is 0.51 inch of water column. So can you tell me for 45 feet of duct length, how much friction loss? Let's say X. Do the cross multiplication and find out the value of X. 0.05, 0.51. Tell me the value, please. Open the calculator. 51 into 45 divide by 100. So it is near about 0.229 and other student 0.23. 1 minute. 0.51 multiplied by 45 divided by 100. 0.23. Yeah, correct. Near about 0.23. Means in 45 feet of duct length, the friction loss value which we have got is 0.23 inch of water column. Okay. So same formula I have applied in the Excel sheet. When you see, we have got same friction value. Total friction in 45 feet of duct length is how much? See, D3 into E3 divided by 100, 0.23. Is it clear? This understood? In the first section, don't need to consider the static pressure because we can calculate the static pressure because the formula is what? First, we need to calculate the velocity at that section. Then only it is possible. So just leave it as it is. Equivalent duct diameter, we have calculated 22.1. Now rectangular duct sizing. This is the formula. See, simple. V1. So for rectangular duct sizing, just already we have done. Open the MEP duct sizes software. How much duct size? Tell me how much size is available. First, you have to see that how much space is available above the false ceiling to run the duct. So when you see here, we are considering, suppose, let's say here it is written clear. Suppose the height of duct as per roof ceiling condition, we have to consider maximum height as per roof ceiling condition, 16 inch. Okay. 16 inch. Up to 16 inch height duct you can select. Okay, so no problem. What I am doing, open the MEP duct sizes software for same flow rate, 8000 and everything. Height I am writing 16 inch. As per that, you will get the width, 26 inch. So now let me know the aspect ratio is satisfying or not for this size of duct. 26, I have told you aspect ratio what? Longer side. Yes, longer side of duct by shorter side. So 26 divided by 16. It is near about 1625. It means the aspect ratio is satisfied. So can we take this size of duct? Yes. Let's say if you have only height, you can suppose you can height available as per false ceiling is 14 inch. Okay. So when you go for 14 inch, that size is coming, width of duct is 30 inch. So when you calculate the aspect ratio, yeah, 2.1, you can select this size of duct also. But yeah, here I am considering in my case, suppose the height is available for duct side, height I am taking 16 inch. As per that, width 26 inch we have got. Okay. So I'm writing it. Try to understand all of it. If anyone have any problem, so you can ask me, okay? 26 inch by 16 inch. So I'm writing the values 26 inch by 16 inch. Okay. So here in A section, size we have got 26 inch by. See the same way. Here I'm repeating all of you. Someone are telling. See, it is simple. Here I have taken one example. Okay. From the HU, we are supplying 8, suppose from the heat load calculation, we have got 8,000 CFM. In our industrial application, total 8,000 CFM we need to supply. So here we have done the diffuser selection. Suppose 8 number of total diffuser. I have decided to place total 8 number of diffuser. Okay. So if total air CFM is 1000 and you have selected 8 number of diffusers. So each diffuser CFM is what? 1000, simple. Okay. So first we are doing the sizing for 8,000 CFM. This in section A, duct size is how much? So by using static friction method, same way, because here I have written the flow rate, then velocity I have taken 3000 because I have told you as per carrier air system manual for industrial application in the main duct for supply air duct, the velocity we can maintain up to maximum 3000. So I have taken 3000. Okay. So if you know the flow rate and velocity, so other remaining other parameter like friction loss value in 100 feet of duct line, you can easily get from the software. Okay. When you enter any 2 parameter, you will get the remaining parameter like friction value, friction loss value, and equivalent diameter also, and rectangular duct size. Okay. So in this way we have calculated. Now come to next section. All of you clear at this point? Tell me, please. All of you clear how I have calculated the duct size for section A? Yeah, other student, tell me, please give me reply in chat box. Yes, no, only you have to type Y or YES. So it is very simple. So please give me reply, okay? Yes or no, okay. So clear. So let's see for next section. Next section is B section. So what is the flow rate here? If you are supplying 1000 CFM in this diffuser and the remaining 1000 CFM in this remaining. So the remaining CFM is what? Total is 8,000, 1000 here, 1000 here. So remaining in section B, remaining CFM is 6000 CFM. And the total length of duct is 40 feet. Okay. So now I'm writing here section B. Okay. 6000 CFM and total length 40 feet. But here the problem is how much velocity now we have to select. Yes, let me know. How much velocity? Okay, in the main duct in the starting we have considered 3000, but we know that now gradually the velocity will reduce. Okay, when you go far away from the AHU, so automatically the velocity will reduce. Now, so how much velocity we have to consider? So remember, let's say for example, just example, okay? I'm just using velocity, I'm reducing and I'm taking 2800. Velocity, how much we have taken? Suppose 2800. Now you have to check it. For 2800 FPM velocity, the size of duct means this velocity which we have taken, it is correct or not? How you will get the idea, this thing? 2800 velocity in section B is correct or not? Remember, I have shown you one, see here in PPT, I have shown you the condition here. See, always you have to satisfy this condition. Friction loss value should always be less than equal to static regain or static regain value. Okay. You have to see the condition. If this condition is satisfying, it means you have selected the correct velocity. Okay. So let's see and tell me 2800. So I'm using the duct sizes software. where it is here. So write down the value 6,000. Clear this thing? Tell me fast, all of you. Please give me reply. 6,000. And now, sorry, 6,000. Velocity, I'm using 2,800. Okay. So as per that, how much head loss we have got? 0.51. And equivalent diameter, 19.8. Okay. So equivalent diameter, we have got 19.8. So I'm writing here 19.8. Okay. And inches. And friction loss value, we have got same 0.51 only. So I have written here. So as per that, when you see the friction loss value, because total duct, this friction loss we have got in 100 feet of duct length. For 100 feet of duct length, friction loss value is 0.51. So our total duct length for section B is 40 feet. So for 40 feet of duct length, how much friction loss? Same formula is there, 0.204 something you will get. Okay. Now you have to calculate the static pressure. So yes, same formula I have applied. You can see 0.9. We see same formula, static pressure. R is multiplied by square of V1 by 4,000 minus square of V2 by 4,000. R is what? Recovery factor. Their value will be between this range 0.5 to 0.9. So here in our calculation, I have considered 0.9. You can see. Then C3 by 4,000 means C3 means what? V1. Okay. Initial velocity at previous duct section means at section A. Okay. Then divide by 4,000 square of that. Then velocity at current duct section means 2,800 divided by 4,000. So when you same formula, when you apply here, you can see it is given formula. How much static pressure we have got? Tell me now, please. 0.065 inch of water column. Now here you have to check the condition. Your friction loss value should always be less than equal to static pressure. So here in this case, can you tell me the friction loss value is 0.2, static pressure value is 0.065. So can we select this velocity? Tell me, condition is satisfying or not? Friction loss value is less than? No, you can see here the friction loss value is coming more than static pressure. It means here the velocity which you have selected is not correct. It means little bit more you have to reduce the velocity. As per that, you have to do the duct sizing. So right now I'm changing it because that is why I'm telling this is our hit and trial method here. It is very complicated. You have to check the condition for each, whatever velocity you are taking. In the main, in the starting, okay, 3,000. But the remaining section, suppose let's say now I'm assuming 2,400 velocity, 2,400 FPM. As per that, I'm calculating the remaining thing. So open the duct sizer, 6,000 CFM, velocity how much? 2,400. So as per that, how much head loss we have got? 0.344. Head loss value is, sorry, head loss value which we have got, if I have taken 2,400 FPM velocity, 0.344 and equivalent diameter 21.4. So, okay, I'm writing in Excel sheet. So 0.344 inch of water column per 100 feet of duct length. But our total length is 40 feet. So for 40 feet of duct length, friction loss value is 0.138 near about. Okay. And how much equivalent diameter we have calculated? 21.4 na? 21.4 inch. So I'm writing here 21.4 inch. So now tell me the condition. See here the friction, as when I have selected the velocity 2,400 for this B section. So the friction loss value is 0.138 and static pressure value is 0.182. So now when you see the condition is satisfying now. Now your friction loss value is less than static pressure value. It means the condition is satisfying. It means what? The velocity which you have selected, it is right. As per this velocity only, you have to do the sizing, duct sizing. So as I told you, in the main duct, we are maintaining 16-inch height. Okay. So better is to consider that height only. Okay. In the main duct, always try to maintain the constant height. Okay. So for 16-inch height, how much size we have got? 24-inch width. Na? So, okay. So I'm writing here. Now, section B duct size is 24" by 16". Am I right here? This is also a main duct. So Control C, V. Now come to next section, all of you. Come to next section means section B. Suppose if you're supplying 1000 CFM here in this diffuser, 1000 CFM here. So the remaining is 4000 CFM and the total duct length for section C is 40 feet only. So, okay, write down section C. Here write down 4000 and 40 feet total length. Okay. Now, can you tell me anyone how much velocity we have to consider now? Tell me now how much velocity we have to take. So here we are not getting any idea. Here, no, don't need to take 2600 Mujib. Why you are taking? Because in previous section B, we have taken 2400 FPM. So how it is possible in section B, velocity will reduce na slowly when you are going for farthest far away from the AHU. Okay. Okay, someone are telling me take as a 1800, some are telling some other, okay, no problem, whatever. So let's say, because we don't know, we have to see the condition, okay? So here I'm assuming, we know that only one thing, that velocity will reduce. So in the previous section, I have taken 2400. So let's say, here I'm trying to take 2000, let's say, this one, 2200 FPM, okay? So as per that, we'll calculate and we'll see it is correct or not. Okay. So open your duct sizer, 4000 and velocity 2200. So see the head loss value we have got 0.353 and equivalent diameter that much 0.353. So I'm writing in Excel sheet. All of you listen here. 0.353 friction loss value 353 in 100 feet of duct length. Okay. Now tell me, when we have written, see now the friction loss value is 0.1 something and static. So here see the problem is what? The condition is not satisfying because I have told you what condition should be satisfied. Your friction loss value should always be less than equal to static pressure. But here the friction loss value is coming for 2200. If I have selected 22 FPM velocity, friction loss value is coming more than. So it means this is not correct. So what I am doing, just mark it like this, wrong. Here I am writing, suppose the wrong selection. Now come to next one. Again, C section. Flow rate is same, 4000. Now suppose I'm selecting 1900 FPM velocity. Do that for 1900 and tell me 4000, 1900 FPM. Okay. So as per that, see the head loss value which we have got is 0.243. Okay, 0.243. Open the Excel sheet, write down 0.243. Total section C duct length is 40. So as per that, when you see, yeah, now it is correct. Now it is correct. Tell me, we have selected the right. No, why? Same problem. Friction loss is coming greater than static pressure. It means we have to reduce the velocity little bit more. So suppose just check it for 1700. Better is to check it for 1700 and change the open the duct sizer. Here write down 1700. So for 1700, for see the friction loss 0.184. Okay. Now I'm writing 0.184. So write down 0.184. Sorry, 0.184. Now the condition, see, now the friction loss value is coming less than static pressure. So you can select this 1700, no problem. But let's say I want to check for 1800 also. Let's say I want to check for 18 because for 1900, when we have selected the velocity 1900 FPM, in that condition, we have not get the friction loss value less than. But let's say if I'm going for 1800, for example, I want to check for 1800. So first now, in MacWit's Duct Sizer software, you have to check 1800 FPM here and 0.212. Okay, friction loss is 0.212. Remember this value. Now I'm writing here 0.212. See, can we select this also, na? 1800 FPM. When you are selecting 1800 FPM, then also the friction loss value is coming less than static pressure. So you can go for 1800 first. Okay. So in this way, we have to do. Okay. Now tell me the diameter, equivalent diameter and duct sizing and everything. So for same 1800 FPM velocity, diameter is coming 20.2 and the duct size 16 means 21 inch by 16. So can we select this one? Okay. So 20, tell me first, 20 by what? Equivalent diameter 20.2 and duct sizing. When you see the duct sizing is coming 21 inch. Tell me here. Sorry, not here. 20. 20 by 2. Tell me the duct sizing. 21 inch by something is coming. So always remember, as I already told you, don't need to select because fabricator will manufacture the ducts some standard size. Okay. So don't need to select the odd number here. Better is to go for 22 inch. Okay. Duct will always fabricate the number 22 inch by 16 inch. Okay. Now it is right. This is the main duct. So you can copy it. So all of it clear up to here. Tell me fast. Yes, please. Tell me, give me reply, please. All of you understood up to here? Anyone have doubt? Clear this thing? Now, let's come to next session. Next section means section D. So what is the flow rate now? 2000 CFM and the total length of section D is 35. Okay. 2035. Okay. So let's see. I'm writing here section D 2000 and we know this one. Now velocity here, let's say assume any velocity because velocity we have to take. Suppose 1500 if I'm going for 1500. Okay, let's check for 1500 condition is satisfying or not. So here just change the flow rate as a 2000 now. Okay, velocity I have taken 1500. So as per that head loss, how much friction loss value? 0. In 100 feet of duct length, friction loss 0.204 inch of water column. 0.204. Okay. So just open the Excel sheet and write down 0.204. So as per that, here you have to apply the formula. So tell me, for 1500 FPM, friction loss value is coming greater than static gradient. It means here the condition is not satisfying, means the velocity which you have selected is wrong. Okay, so don't do the sizing, that sizing as per this velocity. So here also I'm just marking red, yellow color. Now same for same section, 2000, suppose reduce the velocity as a 1300 and check it for 1300. It is, we are getting or not? Please tell me, please. 0.143. See the head loss value, 0.143. Okay, remember this thing. 0.143. So now I am writing here 0.143 and the total length is 35 only. So write down 35. As per that, see now. Now it is clear. Size is correct. Means the velocity which we have selected is right. Yes. Why? Because here the friction loss value is coming, see, less than that. But remember, I have selected 1300. First, you have to check it for 1400. Maybe for 1400 FPM, maybe the condition will satisfy. So, okay, we'll try first for 1400. Okay. Just open it and changes as a 1400 and 0.172 head loss. Okay. 0.172. So I'm writing 0.172. See, for 1400 C, the condition is same, na? Condition is satisfying for 1400 also. So better is to go select the velocity as a 1400. Okay. So as per that, how much you will get the diameter and size, that also we have to see. So 16.2 equivalent diameter, 16.2 inch, and duct size. See, when I'm selecting 16-inch height, width is coming 14 inch. It is possible? No. So you have to reduce the size, 14 inch. 14-inch height, 16-inch width. Now it is clear? Tell me please. 16.2. Here I am writing now. 16.2 equivalent diameter, and the size which we have got 16 inch by. Don't write anything, please. This is also a main duct. Okay, so just copy paste. Clear now? Now the remaining is our branch duct. So up to here, we have done the sizing. All of you clear for main duct, how to do the sizing, how much velocity, how to maintain the velocity, how to use this hit and trial method. Now come to next branch duct. All of you know that in each and every branch, we are supplying 1000 CFM only. Okay. So for 1000 CFM, just write down the branch name, and branch length is 15 feet. Each branch length. Okay, someone are telling me how you get the static pressure value. Asif, I think you're not available when I have discussed in detail. Same way here, we have a formula simple. Okay, R is the recovery factor 0.9, which we have consider. V1 is the previous section. Suppose if you want to calculate the static pressure value for this D section, so simple. See, the recovery is 0.9. The previous velocity at previous section is what? 1800 divided by 4000 square of that. Then current section 1500. So when you apply, you will get same formula here. Okay. Now come to next branch. Okay. Section number 1000 CFM. Just I'm writing now 1000. Clear? And the total length of this branch duct, each and every branch duct is 15 feet. Okay, clear, it is given here. So, okay, we know the length and flow rate. And here I am writing now branch. This is our branch duct. Okay. Tell me now, how much velocity we can take here. So we get the satisfy condition here. Suppose, let's say if I'm going for anyone. 1000. Someone is telling me, okay, we are trying 1000 CFM, 1000 FPN velocity I have considered in branch duct. Okay. Let's say we have to check it now. So open the duct sizer software. Here in branch duct, flow rate is 1000. All of you know that. Clear? And velocity also we are maintaining 1000 you are talking. Okay. Now, see here, as per that, if I'm maintaining 1000, so as per that, see, the head loss is coming 0.113. Okay. 0.113. So you have to see it 0.113, na? So I have written here. See how much we'll get. 0.15 is static pressure, and static regain value. Why it is not showing? 1 minute, huh? Previous section velocity. Actually, okay. 1 minute here. Previous section velocities. So you have to apply the formula here. Actually, C9 it is. C8. Okay, sorry. Here write down C8. Okay, because clear na this thing? Tell me. C8 and C9. Okay, enter. Now you will get. Okay. So 0.017 friction loss and 0.0 static pressure. So here the condition is satisfying or not? Tell me if you are taking 1000 FPM. Condition is satisfying or not? Fast, give me reply, all of you. Yes, we can select this velocity for branch duct. Okay. And now tell me for same velocity, how much we have got the 13.5 equivalent diameter, duct size C. If I'm taking the height 14, I have told you always try in the branch duct, always you have to take the height of duct less than whatever you have taken in the main duct. So you remember that in main duct in the last section, we have taken height 14 inch. So better is what? For branch duct, take the height less than 14 inch. So suppose I'm going for 12 inch. So when I'm going for 12 inch, so the width is coming 13 inch. So don't take the any non-standard value here. Better is to take 14 inch. Okay, 12 inch by 14 inch and equivalent diameter that much. So okay, open the Excel sheet, write down 14 inch by 12 inch we have got. Equivalent diameter, how much we have calculated? 13.5. Okay, so I'm writing 13.5. Am I right now? So in this way, you have to calculate the duct sizing. As per which method? Static regain method. Okay, so it is very interesting. So if you know this all three methods, so now it is very easy for you. If you are doing for residential application you are designing, or for commercial, for industrial, now you get the idea. Okay, like this, where we have to use the equal friction. So let's say quick revise, where in which application quick equal friction method we are using for residential and commercial application. Okay, same way velocity reduction method we have to use where there is no issue of cost, where cost is not an issue. Okay, like if you are designing for luxury apartment, for deluxe apartment, for palace, so better is to go for velocity reduction method. Okay, now next, static regain method is generally used for industrial application, where your, as I told you in starting, this method is used for high velocity system with long duct run. All of you know that in industrial application we have a long duct routine. Okay, so better is to use this method for now. So as I already told you in starting, that in the end of the class here we have completed this three method. Now in starting I have told you in the end of the class we'll uh, tell you about the what we are giving you. Some specials offers are there. Actually here we have already launched the complete pre-recorded course, HVAC designing pre-recorded course. Okay, because we know that many of you are the working professional and you are not getting that much of time, okay, to join with us in live class. So no problem. We have also launched the complete HVAC pre-recorded course. So if you are interested, remember here I will give you the 50% discount. Okay, so I will share you in your that okay, in your chat box, all of you see, I will share the link, payment link. Okay, so both link are there. All of you getting this link? INR payment link is also there. USD payment link, both. So if you are from India, so use the INR payment link. If you are from other country, so USD payment link is also there. So by using this link, you will get the complete HVAC designing pre-recorded course. Okay. How much rupees? Only 4,900 rupees, means near about $17. Sorry, $75. Okay. How much rupees? 4,999 rupees. But remember, this offer is only for last 20 minutes. Okay. Only for those students who are available in this webinar. So they will get the course for 4,999 rupees. Otherwise, same course you will get, same course you will get. I will show you the regular course detail, regular fees. See, you can visit our website also, no problem. So in that website, you will get the complete detail. What? www.augmintech.com. In that, you will get the complete detail. So let's see. when you open this course, HVAC Design Complete course, all of you tell me my screen is visible, na? So here already see how many students have enrolled in this course. Near about 364 students are already enrolled in this course. 5-star rating is also given here. So what will teach you? See, the regular fees is given here. Near about when you buy it from the website. So you will get 9,999 rupees you have to pay it. But here I have given you the 50% discount. So that is why I have shared the payment link, coupon link. You can use that link to buy that course. But remember, again, I'm repeating, this offer is only for last 20 minutes. So what we are giving you, that also I will see what you will learn in this course. Complete syllabus will teach each and everything in detail. Okay, fundamental knowledge. Okay, some basic fundamental of HVAC system, air conditioning process, everything, each and everything. Introduction, basic concept here, whatever we are teaching, everything. Psychometric details are there. Even cooling load, heating load value also we have calculated manually by using the E20 method, Excel sheet, by using HAP software, early analysis program. Everything is discussed in detail. Okay. See, every topic is written. Duct system designing, their topic in detail is given. I will share you this link in your, you can also, if you want to check it, you can check it. Okay. But do not use this link to buy the courses, because problem is what? You will get regular fees is 9,999 rupees. Okay. Near about $150. So I have shared you that payment link. So if anyone are interested for this pre-recorded course, so you can contact with us. Sorry, you can use that payment link. Okay. And you will get the access in 24 hours. After 24 hours, you will get the access. Okay. Only in 4,999 rupees. So please use. And if you have any question or need further assistance, so feel free to reach out to us on the provided WhatsApp number. You can see in your chat box, I have shared the WhatsApp number. You can contact in the given WhatsApp number if you have any question or any further assistance. Okay, so better. So reach out in the given WhatsApp number. Suppose if you are interested for live class, if you are interested for this. But remember, this offer which I am showing here is only for last 20 minutes. So here I am sharing you this thing. Okay. So again, I am repeating this INR payment link is for Indian. If you are from India, so you can use this payment link. And if you are from any other country, so USD payment link is also there. You can use it. Okay. So now anyone have any question regarding enrollment? Okay. So you can ask me in chat box. Okay. Tell me, anyone have any question regarding this enrollment, any doubt? If you want that all, I have already explained you. So remember, this is right now it is 9:26 p.m. So you have only 15 minutes to enroll by using this coupon discount code on coupon link. Okay. Again, I am sharing. So you can use this link. And if you have any further more detail, you want to know more detail about this enrollment process, you are facing any problem, like any question you have, you need further assistance, so you can contact in the given WhatsApp number. Already I have shared that contact number in WhatsApp number in your group, so you can. And one more thing advantage is, remember, who will buy the course, this course, pre-recorded course, so we'll give you the recording of today class also. So you will get the access of this, whatever we have teach now here, you will get the recording access class also. So this is the benefits you will get. Okay. We'll give you the setup file, everything. Hi, yeah, Rizwanullah. This course will contain full entire HVAC topic, because I have already shown you, see, here the complete detail syllabus of that HVAC course. You can see in the screen what you will teach you. See, detail is given. First, introduction to the HVAC world, everything, basic concept, psychometric, okay, psychometric processes, then cooling load value, manual, then by using E20 method, by using HAB software, okay, in detail, duct system, each and everything here, duct sizing, everything you will get. Then see, fan, everything detail, important terms, fan curve, fan law, everything, fan selection you will get here. Air filters topics are also there, types of air filter, selection of filter which we are using in our HVAC system. Air terminal like diffuser, sizing, selection, designing, everything you will get here. Air handling unit, sizing and selection, okay. Hi, yeah, everything. Yes, is one. Chill water piping is also there. See, ventilation, complete ventilation design, car parking, kitchen, toilet, everything you will get. Even here we have also discussed the smoke management system, means smoke extraction system in detail in Excel sheet, smoke stairwell pressurization system, cooling equipment and component like condenser, cooling tower selection, and everything is there. HVAC system in that which topic like VRFC, VRV, VRF system also we have covered here, designing complete. Chiller system, when you open in chiller system, see air cooled chiller, water cooled chiller, chiller design, chiller performance, everything. You will get the cues for each and every section. Ah, yeah, of course, you will get the certification also, na? See here, you will get the certification of completion also, okay? Like this, it is given ISO certified, okay? Everything you will get. See, material include what you will get. See, total duration is given here 21 hours 51 minutes near. Or one more thing, we'll also update remaining other topic. Suppose you will get the remaining all other topics also if you want. Okay, time to time this will update also. So right now we have lots of topic, each and every topic we have covered. But let's say in future, if we'll add more topic also. So okay, so don't worry about that. So duration and certificate of completion also. Material, you will get 21 hours video lectures, even internationally recognized certificate of completion, 200 plus interview practice question you will get. Ebooks also will share you for interview purpose. Okay, Excel sheet, whatever we are using, and total 1000-day access will be give you. Okay, in detail, see in pump also, when you just extend now, you will get each and everything. What NPS, everything we have discussed here. Booster pump selection, chill water piping system. Okay, each and every topics we have covered. So if anyone are interested, so you can tell me. Anyone have doubt? Any? So already I have shared. I'm waiting because 15 minutes is there, because this offer is only for last 15 and 10 minutes are there. After that, same course, same pre-recorded course you will get at what amount? 9,999 rupees. Okay. Again, I am repeating, this offer is only for last 15 minutes. After that, same course you will get at what? Near about 10,000 rupees. Okay. Means around how much? Okay. And if you have any, suppose, any question and regarding this enrollment process, you are facing any problem. So see, I have also shared the, hi, yeah, everything, Rizwanul, everything, installment option is also there. So that is why I have shared the WhatsApp number. You can see in the chat box. So if you have any question regarding this enrollment process, like if you want installment option is there, everything is there. Okay, so you can contact in the given WhatsApp number right now. Just contact it because we have only last 15 minutes. So just contact in the given WhatsApp number. Everything we are offering. Okay, and remember, one more time I'm repeating, the student, if you are from India, so just use this link. Okay, I'm just sharing you INR payment link. And if you are from other cities, so use the USD payment link. Okay. So fast. Now, any other student have any question regarding this one? Hi, yeah, of course, Rizwanullah. You can contact in the given WhatsApp number. Other student, you have any doubt regarding the enrollment? Any problem if you are facing? Yes, tell me, please. Someone are asking me question. Sir, we have 8 diffuser here. You have calculator for only single outlet, but where will we will calculate for all outlet? Do we have to consider the previous velocity P1, for example, in first branch, main branch, we have 8,000 CFM, and from there we are supplying 1,000. So do we have to consider 3,000 FPM as V1? Please explain. That all I have explained in detail, okay? Yeah, Syed Babar, you are talking about how to pay from Pakistan. So same, I have shared the link, see, payment link. You can use it, that link, okay? USD link is also payment links also I have shared in the chat box. And if you are any problem, suppose you are facing any problem in enrollment process, so I will share you the WhatsApp number. You can contact for any question or you need further assistance. So just contact in the given WhatsApp number. Check your chat box. I have shared the WhatsApp number also. Okay, all of you. So you can contact in the given WhatsApp number. Actually, this pre-recorded class we have designed for those students now who are not available, because we know that most of the students are working professional okay. So they are not getting that much of time to take the live class. So for those students we have launched this pre-recorded courses. So in this course, you will get each and everything in detail, and always we are available to help you. If you're facing any problem in between the class, okay, no problem. You can message, will solve your problem. Okay, so don't worry about that. Now, some other student have any problem? Someone is asking me what is time period for complete the course. No, there is no time period. Actually, we'll give you the access for 1,000 days. So you can complete it. Okay, once see here it is written clear. Can you see? Total course duration is around 21 hours, but we'll give you the 1,000 days access. Okay, you will get the 1,000 day access near about 3 years. Okay, so it is enough for you. Clear this thing? Tell me. Anyone? Other? Anyone have? Now the last 10 minutes is remaining. Okay. I have given the payment link also. And if you have any further, suppose you are facing any problem during the enrollment process, okay, no problem. I will also share you the WhatsApp number. You can contact in the given WhatsApp number. So you will get they will help you, okay, for any. So only 7-8 minutes is left, okay. So if anyone are interested, you can enroll it fast. Now, other student, you have any doubt? Anyone you want to know? So each and everything we have discussed here in detail. I think this is the best opportunity, okay. You are getting course a 50% discount. So better is to use it, otherwise, because only for this webinar students we are providing this thing, okay. And already see 364 students have enrolled in this course, and rating is, see, in front of you. I'm not telling anything lie. In front of you it is given here. 5-star rating is also there. So it is depend on you. The topics which we are going to cover, quick review is given here, what you will learn in depth, okay. Everything is given. And time to time we'll update some topic also. Let's say in this, when you see here, the smoke extraction is not written, but we have updated here. See, smoke management system, stairwell pressurization system. Okay. So time to time we'll update also. some new topic will update. So don't worry about that. Okay. So now anyone have any question regarding enrollment process? If you're facing any problem, so let me know. So I am available here. And now for this offer, last 7 minutes is remaining. Okay. So I'm waiting for 7 minutes. So if anyone have doubts, so you can ask me that doubt also, some other problem. So that also I have already shared the WhatsApp number. You can contact in the given WhatsApp number for any other doubt. Okay, clear? And one more thing, I have not sent the brochure. Na? 1 minute. Many of the students are not there. So we'll send you the brochure also. Of if you are interested for live class, so that also available. See, here in your chat box, I have sent the postgraduate program in MEP designing and drafting brochure in detail. So you can prefer that. Everything is written here. For live class, you can use it. And if you are interested for live class, so then also you can contact in the given WhatsApp number. Clear? And if you are interested for pre-recorded course, which I have shared you for complete pre-recorded course of HVAC designing. So I have shared, I have sent already the INR payment link and USD payment link. You can use that link to enroll that course. Okay. Tell me, anyone have doubt now? Last 5 minutes is remaining. Okay. So hurry up and do it if you are interested. Yes. Anyone have any question? Yes, all of you. Someone is asking me, is there any install this one? What is one? What you want to ask? Tell me. Yeah, I'm already I have discussed now. We have that option, installment payment option for this offer price. Yeah, of course. You can contact in the given WhatsApp number. They will guide you. Okay. Already I have explained you, announce you that we have installment option also this one. Okay. You can contact in the given number or Rizwan. They will. No, they will reply you. Don't do not worry about. If you have contact, so they will reply you. No problem. You will get in the same price. Okay, means a discounted rate only. No problem. So don't worry about that because your message, get back to me. Okay, okay. Now other, and I have also shared the MEP complete MEP postgraduate program brochure also. You can prefer that brochure. Okay. Or you can visit our website also www.augmintech.com. In that you will get the complete pre-recorded course, but that is price is high. That is why we have given discount rate. Okay. Anyone have doubt related to involvement? If anyone are facing any problems, so please let me know in chat box. And either you can contact in the given WhatsApp number, which I have shared you. If you have any question or need further assistance, so feel free to contact with us. Okay. Again, I'm sharing the link. Now the last 5 minutes is remaining. Okay, for this price offer apply discount. So if anyone are, so please hurry up and enroll it. Uh, no, Mohammed Usman, already I have in starting only I have announced that we are not providing any recording. Only recording will give you only for those you who have enrolled in this pre-recorded HVAC design pre-recorded course. So for that student, we'll give the recording. Okay. For other student, there is no any other recording. Okay. In starting only, I have announced this all. Okay, Osman. We'll provide the recording, but only for those student who buy this pre-recorded course. Okay. Now, other student have any doubt? You're facing any problem? So any problem if you're facing, so you can contact in the given WhatsApp number. Already I have shared many times the WhatsApp number. You can contact it. Okay. Now the last 2 minutes is remaining for this offer. So congratulations to all those who enrolled in our complete HVAC pre-recorded course. Okay, you will get the in-depth knowledge in that course. So thank you to all of you. Hope all of you enjoy the session. So see you in next one. Okay, so goodbye.